Hi, Algebra 1 students. This is the video for the substitute to show on Tuesday while I am absent. And if you don't have your packets out, please take them out right now and flip to the beginning of chapter 3. We're going to cover 2 lessons today, and there should be time left over for you to work on the homework or to ask each other for help if you need it. So the first topic is relations, and these are going to be done in 4 different ways. One is through coordinate pairs for points on a graph, and then the other is through a table, a mapping, or drawing the graph itself. And so first, let me get my cursor here. So for our vocabulary words and our main concepts, things that this is probably review that you had with your previous math classes, either with Dominique last year or at your previous school. So a coordinate plane is like an XY axis. The X-axis is side to side. The Y-axis is up and down. Your inputs go on the X-axis and your outputs go on the Y-axis. And you'll have a coordinate point, and a coordinate point starts with the X coordinate first. So you'll plot whatever that number is in the side to side direction. And then the second number is the Y coordinate of the point, and you'll plot that up and down along the Y axis. So this whole thing is a two-dimensional flat surface. It's got two number lines called the X axis and the Y axis. And you can represent data by putting coordinate points on the graph. You should label your axes. You can put tick marks, or a graph might be provided, for example, if it's on a quiz, or you can use graph paper if you want for drawing graphs at home. But you can put little tick marks. It's important that you make sure they're equally spaced. And then you can label, you don't have to label every single one, but label a couple of them so that we at least know what numbers we're counting by. So you could count by ones, but you could also count by fives or tens or whatever is convenient based on the numbers that you're trying to graph. The center where the two X and Y axes cross is called the origin. So that's the coordinate point 0, 0. You don't always have to label it as 0, 0, but if someone says the origin, you should definitely know that that's what it means, is the 0, 0 point on the graph. Another word for points on the graph is ordered pairs. This is just a mathematical way of saying the X and Y coordinates of a point. So any given point on your graph, for example, like 4 comma -2, that's an ordered pair. And when you graph it, it makes a point on the graph at a specific location, which is over 4 to the right and down 2, because the X value is a 4 and the Y value is a -2. The X coordinate is just the X part of the coordinate pair, which is how far the point is left and right. And the Y coordinate is just the second part of the ordered pair, which is how far you are up and down. So all that vocabulary word hopefully is review, and it just allows you to talk about the locations on a graph and make sense of coordinate points and where they are on the graph. So all that is kind of captured here in this table as well. I drew a little graph up here so you could kind of see it materializing in real time. But this graph contains all that same information. So x-axis up and down, origin at the center. You can label it with an O if you want. You don't have to. Coordinate points are ordered pairs, et cetera, et cetera. So let me clear this stuff off and then we'll move on. Okay, so what about the other ways to represent this information? So you can do what's called a table or a mapping or a graph to represent the coordinate points. So far, we talked about the coordinate points themselves and then putting them on a graph. So the two other ways that you can do it are a table or a mapping. And then I'll come back to relation in just a second. So a table is a way of showing the same data points, but you're writing all the X values in one vertical column and then all the Y values in a second vertical column, and you're lining them up. So when the X value is a 1, the Y value is a 2. This is the identical information to writing a coordinate point 1 comma 2. So why is one method easier or better than the other? It just depends on the context of what you're doing, whether you present the data in a table or whether you present the data as a set of ordered pairs. Both of these table or ordered pairs would lead to the same graph if you actually plotted the points. Okay, and there's one more way of doing it, which is called a mapping. This is the one that students often have trouble with because it's the one that you may have never learned before. So let's jump over here to the mapping. In a mapping, you're separating out the X part, which is the set of all inputs, which is your domain, and the range, which is the set of all outputs, which is your range. Now, in this one, it looks kind of silly because each input has an arrow straight across to one of the outputs. But sometimes you have a certain value show up more than once in the domain or more than once in the range. And if that was the case, you might have, like, say you had the point 1 comma 0, then you would have to add a 0 to the range because that's a new possible value for the Y coordinate. but you don't have to add another one to the domain because you already have a one. Instead, you would draw an arrow coming off of it and it would go over to here. So you can have one value of your domain branching off to two different things in the range, or vice versa. You could have a couple different things in the domain all pointing to the same value in the range. And we'll see that when we do the example problems in just a second. So just more vocab here, and then make clear and scroll down. Okay, last little bit before we start our example. So any relationship between, oh, sorry, I skipped one. Let me go back up here. I skipped the relation. So let me remind you. The word relation, the vocabulary word relation is just any set of ordered pairs, and they could make a straight line, they could make a parabola, they could just be a bunch of random dots. But the name of that collection of data or that collection of information is just called a relation. Somehow there's a connection between the input x values and the output y values. And then lastly, domain and range are shown very nicely in a mapping, but they're also shown by the ordered pairs themselves or the table or the graph. So the domain is the set of all the possible inputs. So it would be all of the x coordinates that you have in your ordered pairs, or all the different x coordinates that you have in the table, or all the different x values that you have on the graph, or in a mapping, it's just all the numbers that are in your domain box. Then the range is a set of all the outputs, which are usually the y coordinates. So again, it's all the y coordinates from your ordered pairs, all the y coordinates from your table, all the y coordinates from your graph, or all the numbers that are in your second box in your mapping, your range box. Okay, so with that stuff in mind, let's look at a couple of tips and then do the examples. They will all make more sense. If you're a little confused, it'll all make more sense once we start doing the examples. Okay, so any relationship can be shown using any one of these four types. So we're just going to practice, okay, given one or two of these, convert it into the other ones to show the same information in multiple ways. So there could be multiple points with the same x or y value, and in your graph, they'll show up above each other or side to side. In the mapping, you'll have two arrows coming off or two arrows coming together if that happens. So here we go. First example. Create a table and a mapping based on this graph. Okay, so to make a table, we're going to have the x or inputs and the y or outputs. And then we're going to fill in. So you just pick your coordinate points like this first one, -2, 11. We just put the x coordinate is -2. The y coordinate is 11. Then the next one, we'll put in -1 and 8, 0 and 5. So you're just taking all the coordinate points and you're writing them in a table. You typically want to make the x coordinates go in order from left to right, from smallest to largest. Then the next one here we have is 2, -1. Okay, now to make a mapping, we're going to have the input, which is your domain. Sorry, it takes me a little bit to write these because I'm using a mouse. And then we're going to have the output, which is going to be the range. And then you just draw a box, and it has to be big enough to fit all the numbers into it. And then the same thing for the range, draw a box, fit all the numbers into it. So in this case, it's nice to just look at our table. So we have the values -2, -1, 0, 1, and 2. And then in your range, I actually usually put these in order as well. So I'll actually put these in the opposite order. So -1, then 2, then 5, then 8, then 11. And then when we draw the connecting arrows, it might be nice to make it maybe more clear. So I can try to use a different color here. So like the 2 connects down to the 11, then the 1 connects to the 8, the 0 connects to the 5, and that's getting a little bit messy. So let me change colors here. The 1 connects to the 2, and the 2 connects to the 1. I know it's a lot cleaner if you would put the range in the reverse order, but typically when you're listing the domain, you put them all the values in order from smallest to largest, and the range is also all the values from smallest to largest. So because the data is decreasing, the domain and the range are out of order and all the lines look absolutely crazy. So that's just what happens sometimes. Okay, so let's go on to the next example. You can pause the video if we need to, or if kids need to ask a question or clarify, just have them work together with each other to make sense of this, and then move on when everyone's ready. Okay, so given the coordinate points, create a table, a mapping, and a graph. And I've already kind of laid it out for everyone nicely, so you don't have to draw this stuff yourself. So to make the coordinate points, we're just going to take all of these points and we're going to draw them into a graph. So you might want to label X and Y for input and output. So the first one will be 6, comma 3, 5, comma 5, 2, comma -4, -3, 0, 0, 1, and -2, 5. The reason there's an extra line at the bottom is I guess I meant to say X and Y at the top instead of one above it, but how it is fine. Now, on our graph, we can go 6, comma 3 means go over 6, up 3. Wherever you put a point, you want to actually label. So like this is a 6, this is a 3, where that point is. Next is 5, comma 5. So over 5, up 5. Again, we're going to label this one as a 5 right here. And then we're going to label this one as a 5. -2, +2, -4. So +2 and then down 4 puts us right here. So that's 2 and that's down 4. -3, comma 0 is going to be right here. That one we just have to label -3. 0, comma 1 is right here. That one we're going to label as a 1. And then -2, 5 is going to be -2, up 5. -2. Okay, so here's a point. Here's a point. Here's a point. When you're graphing them, if you circle the points that are your final answer, it makes them kind of pop out and a lot easier for someone to understand when they look at it. So this is a nice way of showing it. Okay, over here we've got our domain and our range, or our inputs and our outputs. Input and output are basically same meaning as domain and range. So here we're going to put them in order. So look over at your values and put them in order. So -3 will be first, then -2, then 0, then 2, then 5, then 6. And then over here for outputs, we're going to have -4, then 0, then 1, then 3, then 5. Okay, and now we're going to connect them using lines. And so we have to just go. So 6, comma 3 means I got to connect my 6 to my 3. If I have an input of a 6, I have an output of a 3. 5, comma 5 is going to connect here, 5, comma 5. 2, -4 will connect to -4. -3, 0 will connect -3, 0. 0, 1 is going to connect here, 0, 1. And then -2, comma 5. This one is cool because the -2 has to connect down to the 5. And let me choose a different color just to kind of highlight this bit. The -2 connects to the 5. So the 5 has two different things connecting to it because it was an output value twice. So both of these have the same output value of 5. So on the mapping, two different things both map onto a 5. Okay, again, pause it if we need to give people time to copy it down or to ask questions about it. And then when you're ready, we can move on. Okay, I'm actually going to stop the video right now and then make the next one a separate video. So just give me a second. Stop.